In this lesson, we are going to learn how to predict the solubility of chemical compounds, and then we're going to be able to apply that to double replacement reactions and predicting whether or not either of the products are soluble, or if one will do what we call precipitate. So to start, we have to become familiar with how to use reference table F, which are called solubility guidelines for aqueous solutions. Aqueous solutions just means that they are dissolved in water. So we are looking at whether or not these compounds are soluble in water or not. Okay, and so what you need to recognize is this chart has two very different sides to it. These are ions that will form soluble compounds. So if you see any of these ions in a compound, they will be soluble, unless the exceptions are noted. So for example, halides, chlorides, bromides, iodides, any substance that has those halogens in it are soluble, except if the halogen is combined with a silver, a lead, or a dimercury. Sulfates are soluble in water, except if you have silver sulfate or calcium sulfate or strontium sulfate, barium sulfate, or lead 2 sulfate. Okay. But things like group 1 ions, lithium, sodium, potassium, if you see a compound with lithium, sodium, or potassium, it will always be soluble. Ammoniums are always soluble. Nitrates are always soluble. Acetates, always soluble. Hydrogen carbonate, bicarbonate, always soluble. Chlorates, always soluble. All right, so over on this side, we have ions. If you see these ions, they are said to be insoluble. They will not dissolve in water. So carbonates are not soluble, except if you have them combined with a group 1 ion. Remember, lithium, sodium, potassium. Anytime you have lithium, sodium, potassium, it'll always be soluble, even when it's with a carbonate. So these carbonates are insoluble, except if you see it's with a group 1 ion, the alkali metals, or if it's with ammonium. Remember, we said ammonium is a cation that's always soluble. Chromates are insoluble, except when they are with those group 1 alkali metals, or if you have calcium chromate, magnesium chromate, or ammonium chromate, those will be soluble. So insoluble unless this situation is true. Phosphates are generally insoluble. Put them with an alkali metal, put them with ammonium, they'll be soluble. Sulfides, generally insoluble, but put it with an alkali metal, put it with an ammonium, and it will dissolve. Hydroxides are insoluble. Quite a few more exceptions here. If you put a hydroxide with an alkali metal, like sodium hydroxide, lithium hydroxide, potassium hydroxide, it will be soluble. Calcium hydroxide, barium hydroxide, strontium hydroxide, or ammonium hydroxide, those situations, the hydroxide will dissolve. But anybody else, hydroxide is insoluble. Okay, so that's kind of how you have to think through this table. So we're going to try a few examples here. So is zinc sulfate soluble or insoluble in water? So you have to kind of look at this formula. There's nothing in here about zinc as a rule, so you have to treat this as a sulfate, right? So the anion in this formula is a sulfate, which is SO4 minus 2. When we find that anion in reference table F, we are going to find the sulfate here. The anion is categorized as soluble, right? Because sulfates are soluble. The cation in the chemical formula is zinc, which is Zn plus 2. Is the cation one of the exceptions? Nope, it is not. So the final decision is that zinc sulfate is soluble. Okay, there's no exception, so it is soluble. All right, let's take a look at Mg3PO42. The anion in this case is phosphate, which is the PO4 minus 3. Find that ion in the table F. There it is. It is categorized initially as insoluble. The cation here is magnesium. Is that one of the exceptions? No, it is not. So therefore, magnesium phosphate is considered to be insoluble, right? So here's two very different situations. Soluble means it will dissolve, and insoluble means it won't dissolve. All right, let's take a look at KNO3. Is KNO3 soluble or insoluble? The anion here is NO3 nitrate. Find the anion in reference table F. It is up here, right here. It is listed as a soluble ion. The cation is K+1 potassium, and it is not. There are no exceptions, so the final decision here is that it is soluble. It will indeed dissolve. Okay, so that's how you use, oh, I guess we have one more example on the next page. Let's take a look at this. Is AgCl soluble or insoluble? Put the chart down here. The anion here is chloride, Cl-1. That's right. Chloride here is soluble. There are some exceptions. Silver, lead, or dimercury. So we found the anion. We find that it is indeed soluble. The cation, however, Ag+1, yes, it is one of the exceptions. So that makes AgCl insoluble. It will not dissolve. Okay, so that is how you see the different scenarios that work in reference table F. So speed round, taking a moment using reference table F, predict which compounds are soluble in water. Write soluble or insoluble after each chemical formula. Okay. So a couple things to recognize. If you see ammonium or you see nitrate, either one of those are always soluble. Okay. Do you have to see both of them to decide it is always soluble? No. If you only see one of those, automatically you know it is soluble. Okay. Bromine. Bromide is one of the halogens right here. Okay. There are exceptions to bromide solubility, and that's silver, lead, or dimercury. That is the case here, so this is going to be insoluble. The next one, Na. Anytime you see an alkali metal, this is going to be soluble. All right, 4, very much like 2. It's a halogen. Cl is a halogen. Normally, chlorides are soluble, but when it's with silver, it's going to make it insoluble. Okay, 5 is a little tricky. It doesn't have like an absolute choice here. We're looking at hydroxides right here. Hydroxides are insoluble, but when they are with group 1 or calcium, barium, strontium, or ammonium, that will make them soluble. So here we have a hydroxide, which makes it insoluble, but with calcium, it's going to be soluble. Okay, this one right here, calcium carbonate, that's a carbonate. Insoluble, except when it's with group 1 or ammonium. That is not the case, so this will stay insoluble. We have a sulfate here. Sulfates generally are soluble. There are some exceptions. Aluminum is not listed as one of those exceptions, so this will be soluble. Calcium sulfate. Sulfates are soluble, except calcium's an exception, making this insoluble. Number 9, isosodium. That's a group 1 element. It is an alkali metal, soluble. Lastly, I see phosphate. I think we just saw this one in a previous example, but we have phosphate, which is insoluble. Magnesium is not one of the exceptions for phosphate, so this is going to remain insoluble. Okay, so that's how you can get kind of quicker at doing those. Now, let's apply this to the solubility of compounds in a double replacement reaction. We need to look up the solubility of each compound. And if it is soluble, that means it is aqueous. Okay, so if you find that it's soluble, that means it stays dissolved in the solution. We classify it as aqueous, and we use the abbreviation AQ. So soluble is AQ. If the substance is insoluble, that means it is a solid, and we use the S in parentheses to indicate that it is solid. We also sometimes say that it is a precipitate. A precipitate is where a solid forms where there was no solid before. So let's try KBr. First thing I see here is potassium. Potassium is a group 1 ion. It is always soluble, therefore it is aqueous. AgNO3, I see NO3, I see nitrate. Nitrates are always soluble, right? And I'm just looking right here. Nitrates are soluble. There are no exceptions. So soluble means aqueous. KNO3, here we have the potassium, or you could say here we have the nitrate. That's going to make it soluble and therefore aqueous. AgBr, right? We saw that up above. AgBr is insoluble, so this is going to be our precipitate. Right? That's going to be our precipitate. All right, let's take a look at the next one. Na2SO4, sodium sulfate. I see sodium, that's a group 1 ion, it is aqueous. Here we have chloride, right? Here we have chloride, which is here. So chlorides are soluble. There are exceptions when they're not soluble, but strontium is not one of them, so this is aqueous. When we make new combinations, we're going to have sodium chloride together. We know because of the sodium, this is going to stay dissolved, so therefore aqueous. Our next decision is based on strontium sulfate. Sulfate is soluble, except strontium is one of the exceptions, so this will not stay dissolved. This will become a solid, and this will be our precipitate. Okay, let's take a look at the next ones. HCl, this is a chloride, which are soluble. There are a few exceptions, but hydrogen is not one of them, so this is aqueous. Sodium, I see a sodium, it is aqueous. I see sodium over here, this is aqueous. And I see water as the other product. Water cannot be aqueous. Water cannot be dissolved in itself. This is going to be a liquid. Okay, so this is, we would say here that there is no reaction because no precipitate is formed. Okay, last one. Na2S. Sodium is present. It is aqueous. HCl, we already decided from an earlier problem, is aqueous. Sodium chloride, we already decided from a previous problem, is aqueous. And lastly, we have H2S. This is a sulfide. Okay, we're looking at sulfide right here. They are insoluble with group 1 ions. That is, group 1 ions is indeed hydrogen. So this is an interesting question here. This is a group 1 ion, right? Hydrogen's in group 1. So therefore, that is an exception. Sulfides are normally insoluble, but when they're with a group 1 ion, they're going to be aqueous. They're going to stay dissolved. So again, we don't have no precipitate is formed. Right, no precipitate formed, so we would say no reaction. Now, in a true double replacement reaction, the reactants are always aqueous. They have to be in order to have a double replacement try to happen. So in a double replacement, the reactants are always aqueous, and typically your job is going to be to determine the solubility of the products. All right, in this lesson, we have learned how to interpret reference table F to decide if a compound is soluble or insoluble. We have learned that if something is soluble, we will classify it as aqueous, meaning it can dissolve in water. And if it is not soluble, if the substance is insoluble, we will indicate that the state of matter is a solid, and we refer to that substance as being a precipitate. All right, that is it for this lesson. We will see you back in the classroom.